So day 10 of a question a day. This question here is mostly about notation. So where it says we've got this Sn equals the sum from k equals 1 to n of uk, it's asking us to find the sum of, well, u1 when k is 1, and u2 when k is 2, and u3 when k is 3, and u4 when k is 4, and so on, all the way up to un when k is n. Now, earlier on, it tells us what uk means. So u1 would be 11 minus 2 times 1. Right, that's u1. u2 would be 11 minus 2 times 2. u3 would be 11 minus 2 times 3. u4 would be 11 minus 2 times 4. And un would be 11 minus 2 times n. So this we've been asked to sum up this series, and the series is 9 plus 7 plus 5 plus 3 plus whatever the last one is. So if we want to translate it into something that we know about, we know that this is an arithmetic series because it has a common difference. It's an arithmetic series with first term is 9, common difference is minus 2 because they go down by 2 each one, and the nth term, how many terms are there? There's n actual terms, right? So there's a few things we can work out from this if we want, just for discussion's sake. Normally you would say that the nth term of an arithmetic series is a plus n minus 1d. So in this case it's 9 plus n minus 1 times minus 2. All right, that's 9, and then minus 2n, and then plus 2, which is 11 minus 2n, right? Which we can see is the nth term of that series, right? So the other interesting thing is that the common difference is like the gradient. If you write it like a linear function, you know, mx plus c, the common difference is the gradient, and the y-intercept would be the first, would be the 0th term. So what would that be? 11. If you go back to the left in this series, 3, 5, 7, 9, heading leftwards, the 0th term would be 11. So anyway, that's just out of interest. So we've been asked to find here, the question is, obtain a formula for the sum. All right, well, we know there's two formulas for the sum of an arithmetic series. The first one, if you know the first and last term, a and l, we can use that formula. So let's try that. It's n on 2 a plus l. The first term's 9, the last term in it is 11 minus 2n. So it's n on 2, 20 minus 2n. So we divide, that's like n on 2, and then 2, 10 minus n. So we can divide those two. It's n 10 minus n, or you could say it's 10n minus n squared. So you could have got it from doing that, or you could have used the longer formula, n on 2, 2a plus n minus 1d. Right, both of these are available on the formula sheet. Now, by substituting into there, you should get 10n minus n squared. N on 2, 2 times 9 plus n minus 1 times minus 2 is n on 2, 18, and that's plus 2 and minus 2n. So that will be n, and that's 20, but I divided by 2, so 10 minus n, which would be equal to 10n minus n squared. So either way, you get that answer. The answer to that question is that Sn is equal to 10n minus n squared. All right, so we've got ourselves a formula for that sum, and now find the values for which it equals to 21. So in other words, when does 10n minus n squared equal to 21? Or minus n squared plus 10n minus 21 equals 0? I'm going to just times by minus 1. Okay, so I can easily factorise that. Two numbers that times to be 21 but add to be minus 10 is n minus 7 and n minus 3. So n equals 7 or 3. So that's the answer. I think they just said find the values of n, so that's got the answer. Now I'll just show you if that makes sense, all right, by rewriting down what the actual pattern was. So we had, these are our terms, our TNs, if you like. They go like this. They go 9, then 7, then 5, then 3, because we're going down by 2, right? So we'd be 1, then minus 1, then minus 3, then minus 5, then minus 7, then minus 9, then minus 11, etc., right? And the series goes on and on forever. Now, what about if you add up to each point? If you add up to the first term, well, you just got 9. If you add up to the second term, you got 16, don't you? 9 plus 7. Add on 5, 21. Add on 3, 24. Add on 1, 25. Add on minus 1, 24. Add on minus 3, 21. Add on minus 5, 16. Add on minus 7, 9. Add on minus 9, 0. And add on minus 11, right? Now the question said up to which terms, when you're adding it up to which terms, you know, this is the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th. Up to which ones do you get a sum of 21? Well, here's a sum of 21. Which term is that? The third term. But here's also a sum of 21. Which term is that? The seventh term. So it does make sense that there's two possible answers.